What's up, nerds? Let's talk about the quadratic formula. So, this chapter we've looked at different ways that we can solve quadratic equations, and by far the fastest way is going to be graphing if you have graphing technology available to you, whether that's Desmos or your graphing calculator. You can graph a quadratic, you can really graph any function, and the solutions are always going to be the x-intercepts. If you don't have graphing technology available to you, we have a couple other methods you can use. We can use square roots if that's easy enough. We can factor if we have a trinomial or a binomial that's easy to factor. And we just learned in 3.3 completing the square. And all of those are great, but they each have their time and place. They don't work easy always. So the nice thing about the quadratic formula is it is going to work on every single problem. Sometimes it's a little more work, but it works without fail. And this is something you're going to need to memorize. So if you don't already have it memorized, I would suggest maybe looking up a YouTube video, and they have nice little songs that you can learn. I learned the quadratic formula to the tune of Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if that floats your boat, you can use that to help you memorize it, or whatever you want, but it is something you need to know. So let's look at this first example. We have 4 different quadratics, and we get to use any method we want to solve. Use any method. Okay, and in this first one, if you're comfortable enough factoring, you might be able to pretty quickly recognize that there's 2 factors of 63, 9 and 7, that are going to combine to make 2. So I can just by inspection tell that factoring is going to be the fastest way for me to solve this one. Then I can use that zero product property that says that if 2 things multiply to 0, then one of the factors must be 0. So I can set each factor equal to 0, subtract 9 from both sides, add 7 to both sides, and I have my 2 solutions here. We can double check that those are solutions by plugging them back in and making sure it makes the original equation true. Okay, B, we have to remember that solutions, another word, is zeros, so we need to move everything to one side to get it to equal 0. I'm going to write it in standard form there. Okay, and again, by inspection, I can inspect those factors, and there's no factors of 9 that will easily multiply to 4, so factoring isn't going to work, square roots isn't going to work, but completing the square will. So we want to take half of that middle number, so -2, and square it. That's going to be my part of my creative version of 0. So if I'm adding 4, there's no a value in front, which means I just need to also subtract 4 for that creative version of 0. And now I can factor this perfect square trinomial, -13. Okay, and now I can solve with square roots. I can add 13 to both sides. Now I need to take that plus or minus square root of both sides. And I cannot simplify the square root of 13, so it's just going to stay just like that. Add 2 to both sides, and there are my 2 solutions. Remember, this represents 2 solutions. This is both 2 plus the square root of 13 and 2 minus the square root of 13. Okay, so these next 2 problems are interesting, because when we move everything to one side, I guess I got a little ahead of myself. Let's go ahead and move everything to one side first. Plus x plus 4. Okay, and now it's interesting because there's no factors that I can see immediately. I don't really want to complete the square because this number here is not only odd, but after I factor out this a value, it's also going to be a fraction, and I don't want to have to take half of a fraction and square it. Okay, so really, other than graphing, if I had graphing technology available to me, that would be easy. But I'm kind of stuck with all the methods we have so far, and this is where the quadratic formula is going to come in handy. Is as long as I can recognize my a, b, and c values. So a is 2, and notice a, b, and c are just the coefficients. They never involve the variable x. Okay, I can go ahead and plug this into the quadratic formula. For my solutions, or what does x equal? What are those x values of the x-intercepts? Okay, so x equals negative b plus or minus the square root of b squared. Make sure you put b squared in parentheses. That's where a lot of students will go wrong in this. But b squared minus 4ac all over 2a. Okie dokie. So we end up with negative 1 plus or minus the square root of, and we end up with 1 minus 32, so negative 31. Ooh, interesting. We have the square root of a negative there. Okay, so I know that 31's prime, so that's not going to simplify, but I can pull out an I. Maybe I'm going to put this in parentheses just because I've made a big deal about that this year. Okay, and so I have two imaginary solutions here. I have negative 1/4 plus the square root of 31 over 4i, and negative 1/4 minus the square root of 31 over 4 times I. Right, and so the quadratic formula helped me to find those two imaginary solutions. So let's try that out again. Again, on D, once I move everything over to one side, plus 3x plus 13. I can see factoring isn't going to be super easy. Completing the square is possible, but I don't really want to. So I'm going to go ahead and go with the quadratic formula again for this one. A is negative 1, B is 3, C is 13. Okay? And x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alrighty. So negative 3 plus or minus, we have the square root of 9 plus 4 times 3 is 40. 52. 52 plus 9 is 61. Divided by negative 2. Okay, and depending on the directions, right? So since c was a complex number, since I had that square root of a negative there, since it was a complex number, I wrote it in standard complex form. The directions didn't necessarily ask me. Well, actually, let me check. Right? Oh, right, all complex ends are in simplest form. It doesn't necessarily say standard form. So we could have left it as a fraction after we pulled out that I. But since it doesn't say anything about standard form, it is totally fine to leave your answer as a fraction like this. However, I do want to talk about if we did need to split that up, right? That would look like x equals negative divided by negative is going to be a positive 3/2. And then plus or minus, dividing those by a negative, we're still going to have a plus and a minus. Sometimes we can show that we have divided by a negative by switching the order that we write them in. So you can write it like this. That's not something I expect you to do this year though, so if you just want to leave that a plus or a minus, that is totally fine with me. And that's how you would split that up into its two separate fractions there. So Both of those are perfectly good answers as per these directions. All right, so example 2. Use the quadratic formula to find the solutions. Write all answers in simplest form. Alrighty, we can do that. So now I have to use the quadratic formula, which is kind of a bummer because factoring would work for this one. But follow directions. Got to practice. So quadratic formula. Let's go ahead and write down a equals 1, b equals 2, c equals -3. Careful with those negatives. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Alrighty. -2 plus or minus 2 squared is 4. And then we have plus 12. 4 plus 12 is 16. Ooh, this is exciting. We have a perfect square here. So we end up with -2 plus or minus 4 divided by 2. And the order that we simplify this doesn't really matter. So I'm going to go ahead and do -2 plus 4. -2 plus 4 is 2 divided by 2 is 1. -2 minus 4 is going to be -6. And -6 divided by 2 is -3. So I have both of my solutions here. And I want to take a second, I know I'm not completely done, but I want to take a second to look at the last 3 examples that we've done so far. And specifically, what's happening with this square root, because this square root actually tells me a whole lot about what type of answer I'm going to end up getting. We can see on C, I had a negative underneath the square root, which means I'm definitely going to end up with an imaginary answer. Okay, on D I wasn't really able to simplify. I was taking the square root of 61, which isn't even simplifiable. I can't simplify it. It stays an irrational number. So I end up with 2 different irrational solutions. Okay, but A was really nice. A was easy to factor, so it kind of makes sense I got 2 nice answers. But the reason I got 2 nice answers is because that discriminant, we don't know that word yet. We're about to learn a word for what's underneath that square root. It's called the discriminant. That discriminant was a perfect square. So that thing underneath the square root, 16, I can take the square root of, and that's why I ended up with those integer answers. Alrighty, so let's kind of predict, after we do the quadratic formula on B, let's predict what type of answer I'm going to get. So, let's identify A is 1, B is 2, C is 6, X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, -2 plus or minus, and we end up with 4 minus 24, which is going to be -20. And I can already tell, because I have a negative under that square root there, that I'm definitely going to end up with 2 imaginary answers. Okay, so X equals -2 plus or minus, and maybe let's go ahead and split this up since I know it's going to be imaginary. -2 over 2 plus or minus. Okay, and let's actually do some side work. So I have the square root of 4, the square root of -1, and the square root of 5. Okay, so this is going to simplify to 2 square root of 5 over 2 times I. Okay, and I can do a little bit of simplifying then. X equals -1 plus or minus the square root of 5. Remember, be really careful with standard form here and putting that I at the end. We want to make sure it's not under that square root. Beautiful. And again, I already knew I was going to end up with that imaginary answer because of the negative under the radical. So let's talk about that word I accidentally said earlier, which is discriminant. So the discriminant is specifically the part of the quadratic formula that is underneath the radical. Okay, and knowing what that part is, because it's underneath the square root, that tells me a lot about my answers. So if that part underneath the radical is positive or greater than 0, I know for sure I'm going to have 2 real solutions. Okay, because taking the square root of a positive number definitely ends up a real number. If it's a perfect square, I get 2 rational solutions. They might be integers or they might just be fractions, but what I would consider pretty fractions, 1/2, 7/3, right? And that's going to happen if we have a perfect square under the radical. Okay, if it's not a perfect square, then we're not able to simplify the square root, which is going to make it an irrational solution, or really 2, because we have plus an irrational number and then minus that same irrational number. Okay, I'm going to skip to this third example. When the discriminant is negative, we have 2 imaginary solutions because taking the square root of a negative isn't an imaginary number. We know that. Okay, but this middle solution is interesting. We haven't looked at this. When the discriminant equals 0, that means you're going to have plus 0 and minus 0. And adding 0 and subtracting 0 doesn't change a number. So we actually end up with a repeated solution. It's still technically 2 solutions, but it's the same number twice. So since it's the same number twice, we really just say it's 1 real repeated solution. Alrighty. So use the discriminant to find the number and nature. We don't actually have to find the solutions, just number. Is it 1 or 2? And are they real or imaginary? Okay, so all I care about is the b squared minus 4ac. So discriminant equals b squared minus 4ac. Make sure you use parentheses on that b or you're going to get the wrong answer. Okay, so the discriminant equals 4 minus 16, which is negative 12. Okay, so since it is negative, we know we have 2 imaginary solutions. And again, it doesn't ask me what the solutions are, just asks me the number 2 and nature imaginary. Okay, b x equals negative b plus or minus the square root of b squared minus 4ac. Okay, and notice the discriminant does not actually include the square root part of it. It just includes what's underneath the square root. Okay, and I guess maybe on this last one I should have said that discriminant is less than 0. Therefore, there are 2 imaginary solutions. 13 is greater than 0. Therefore, we have 2 real solutions. Alrighty. And let's look at this last example. Okay. X equals negative b plus or minus the square root of b squared minus 4ac. So many negatives in this one. Okay, so the discriminant equals 100 minus 100. which is 0, which I don't really have to say equals 0, but it does. Therefore, we have one repeated solution, one repeated real solution. And some people will word that as 2 repeated real solutions, right? Because it's the same solution twice. That's how it's repeated. But regardless, you know what they mean. Okay, great. So let's look at some of this in action. And especially I want to focus on C and D. So in A, in the given equation, C is a constant. Well, and I guess A too, we really want to focus on. The equation has no real solution if C is bigger than a certain number. What is the least possible value of n? Okay, so no real solutions. When I see this, this is my key on the ACT, and ACT loves asking this question. I know since it's talking about the number of solutions, we're for sure talking about the discriminant. So the discriminant equals b squared minus 4ac. So let's just plug it in. B squared minus 4a, and c is just a variable, but that's what I'm solving for. Okay, and in order for me to be able to solve for c, I need an additional piece of information. I need the fact that I know that no real solutions means the discriminant needs to be less than 0. So I'm going to go ahead and set up that inequality here. And I'm just going to kind of trust the process. We can use our calculator. Because it's an ACT practice problem, right? We can use our calculator on ACT stuff. Okay, and this is important. When I divide both sides by -4, remember that dividing by a negative is going to change the direction of our inequality there. So we end up with C is greater than 289. And fortunately, even if you did not know that this was how you were supposed to solve the problem, by recognizing it was talking about the number of solutions, that's your clue that it's talking about the discriminant. And then just trust the process from there on out. You trust the process and it sets up the answer for you. What is the least possible value of n? N is anything bigger or equal to 289. That sets up exactly what we wanted. So n must be 289. Okay, B, I would definitely suggest you graph it, right? This is an ACT question. You can tell the number of real solutions by graphing. So if you graph it, you should see that this quadratic does not have any x-intercepts. But just to verify, since we're talking about the discriminant, let's see what the discriminant equals. So B squared minus 4ac. We end up with 100 minus 320. That is definitely going to be negative, right? I don't even have to know exactly what it is. I do know that that ends up negative, which means that there are no real solutions, right? And it says real solutions, and that's important. Okay, C. One solution to the given equation can be written as 1 plus the square root of k, where k is constant. What is the value? Okay, well, this is not talking about the number or nature of solution. Well, it kind of is. It tells me one solution is this. Okay, but that doesn't look like the discriminant. That either looks like the quadratic formula, and we simplified it, or we can solve by completing the square, but we are actually looking for the actual number solutions. So however you want to find that. And personally, I want to complete the square because that's pretty easy on this problem. Okay, so here, again, I don't really know what I'm doing with this yet, but that's okay. Trust the process. You're not supposed to know exactly how to solve every problem. The purpose is you can figure it out. Okay, so I know how to complete the square, or I know how to do quadratic formula. Either one will work. Okay, half of this number and square it, which means I need to subtract 1 for my creative version of 1. Okay, factor. Okay, and then again, just kind of trust the process. I'm finding the solution, so I'm going to add 10 to both sides. I can take the plus or minus square root of both sides. I can add 1 to both sides. And I see my answer now, right? Because if I compare what I ended up with to the problem now, it says one of the answers is 1 plus the square root of k. Well, 1 plus the square root of 10. So k must be 10. Look at that. Okay, and D, we're going to kind of do the same thing. Maybe I don't know exactly how to solve it, but I can trust the process. So in the given equation, C is a constant. The equation has exactly one solution. Okay, so exactly one solution. It's talking about the number of solutions, not the actual solution. So look at the difference between C and D. C gave me a solution answer. D is just talking about in general. So in general, one solution means the discriminant equals 0, which means let's go ahead and set up the discriminant and hopefully we can solve for C. So x equals negative b plus or minus the square root of b squared minus 4ac, and c is still just a variable. And for there to be one solution, I know that it has to equal 0 then. Okay, and I can go ahead and use my calculator to simplify. We have 900 plus 36c. 36c is negative 900. And negative 900 divided by 36 is going to be negative 25. Right, and again, even if you didn't know that's how to solve it, looking for those keywords, connecting it to something that we just learned is going to help you problem solve your way there.